Diffblue cover writes Java unit tests automatically without human interaction and without using any external resource. Depending on code complexity, it is sometimes difficult to write useful unit tests, and in this video we'll introduce custom test setup. This is a technique which enables Diffblue cover to appropriately configure and clean up the environment such that unit tests can be usefully written. In this tutorial, we make use of JUnit specific annotations, so it's a good idea to review their scope and use. Let's assume we have a Java unit test class and for simplicity only one unit test method. It's a test method because it's annotated with test. The test method might need some initialization, such as making some resources available, or initializing some fields or spinning up a database, and this can be done using a static method annotated with BeforeAll. This method will be executed only once, just after the class is loaded and before any test method is run. Similarly, final tasks such as releasing resources or resetting back some values to various fields may be required. In this case, we will add a static method annotated with AfterAll, not necessarily placed at the end of the class. This method will be executed only once before unloading the class and after each of the test methods has already run. But we might need additional initial or final tasks before and after each test method runs, as for example resetting the database or values to fields. We can achieve this by adding instance methods annotated with BeforeEach or AfterEach respectively. These methods may appear anywhere in the class and they will be run not on any particular test method, but before and after respectively all of them. Let's consider a Java source class named myClass. Running Diffblue cover, we obtain a unit test class named myClass Diffblue test. This test might not be sufficient, especially when a particular method should be run before or after one or more test methods. We need to make Diffblue cover aware that a particular method must be run before or after unit tests are written. The solution is to add a class name myClass Diffblue base in a test directory. Inside this class, we need to add all methods appropriately annotated which need to be executed before or after the test methods are executed. The next step is to compile myClass Diffblue base, and on a new run, Diffblue cover will replace myClass Diffblue test with a new version which better tests the code logic by inheriting myClass Diffblue base. Custom test setup is a technique developed by Diffblue in order to integrate Diffblue cover with the inheritance model of JUnit. It allows users to control the interplay between the test runtime and values of critical fields in the source code, making use of the before and after annotations. It gives the possibility to construct difficult field inputs which are important in some cases. It also allows users of Diffblue cover IntelliJ plugin to mock Java classes using Mockito. We'll first look at the generic Java project and locate the Diffblue base class. We'll then go through a code example for each of the four annotations: BeforeAll, AfterAll, BeforeEach, and AfterEach. Eventually, there will be an example of mocking with Mockito and an example of setting field inputs. All these examples show the power of custom test setup technique developed at Diffblue. This tutorial contains annotations specific to the JUnit 5 framework. You should use equivalent annotations for JUnit 4 or TestNG. This table shows how different test frameworks use the before and after annotations. The syntax differs, but their functionality is the same. Methods annotated with these annotations must be public. A typical Java project contains a directory named main, where the source code is stored, and a directory named test, where the user or Diffblue cover writes test classes. When writing test for a class from main, Diffblue cover looks in the corresponding package from the test directory if it exists at all. More exactly, it searches for a class with the same name followed by the suffix Diffblue base. If it finds such a class, it will consider it as superclass for the test class which is going to write. This Diffblue base class is where we can add methods which are expected to run before or after the test methods are executed. We need to annotate such methods appropriately, and the annotation type depends on the test framework used. This is an example. Because we are testing my class from my package, we need to add a class named myClass_DibblueBase in a package named myPackage in the test directory. We also need to compile this class before running DibblueCover. The command depends on the build system in use. For Maven, this is nvm test_compile. After running DibblueCover, when opening the test class file, that is myClass_DibblueTest, we can see that indeed it extends myClass_DibblueBase. All examples in this video share this POM.xml file, which calls for the JUnit and Mockito dependencies such that DibblueCover can write assertions and mock method inputs respectively. The Maven Shortfire plugin is also listed because DibblueCover uses it to validate tests after writing them. We use the BeforeAll annotation when we need to call a specific method before running any of the test methods in a class. Let's see an example of using the BeforeAll annotation. Here we have a class named Calculator, which contains 3 methods. We'll focus on the sum method. The class also contains a primitive Boolean field named licensed. The sum method adds 2 integers, but it does so only after calling the checkLicense method. CheckLicense can interrupt the execution of sum by throwing an illegal state exception. Let's run DibblueCover for the sum method. We will use the command dcover_create followed by the fully qualified name of the method. We get 4 tests which partially cover the sum method, more exactly the call to the checkLicense method, but the logic of adding 2 integers, which is vital for this method, remains untested. This happens because the Boolean class field is false, and in order to make it true, we'll need to call the licenseAllFeatures method. Here we can use the custom test setup technique by adding a base class in the test directory, because our sum method is defined in a class named Calculator, which belongs to the package before. We need to identify the corresponding package in the test folder. There we need to add a class named CalculatorDibblueBase, which exactly matches the name of the class that contains our method, followed by the suffix DibblueBase. Because licensedAllFeatures is static in the calculator class, we can use the annotation outBeforeAll to call licensedAllFeatures before the test class is even written, and this will ensure that licensed becomes true. We must now compile the base class, and we can do it here by using the command nvm test_compile. We can then run DibblueCover again. Eventually, the unit test class was rewritten and we obtained unit tests which truly test the logic of our add method. It is important to notice that our new test class extends our DibblueBase class. The BeforeEach annotation marks an instance method which must be executed before each of the test methods is executed. Let's see an example of using the BeforeEach annotation. Here we have a class named Relay, which contains 2 static methods. It also contains a static primitive Boolean field. named getOpen. The open method switches the value of the getOpen to true. The broadcast method takes a string and, depending on whether getOpen is true or false, returns a string or null respectively. Let's run Diffblue cover for the relay class, keeping any partial tests. We can do this using the command dcover_create followed by the fully qualified name of the class and the option keep partial tests. By running Diffblue cover on the relay class as it is, because getOpen is false, we get one test which partially covers the broadcast method. More exactly, the else branch, but the logic of returning a string along the if branch, which is vital for this method, remains untested. Here we can apply the concept of using a base class in the test directory, because our broadcast method is defined in a class relay which belongs to the package before. We need to identify the corresponding package in the test directory. Then we need to add a class named relay Diffblue base, which exactly matches the name of the class that contains our method, followed by the suffix Diffblue base. By annotating an instance method such as enable testing with BeforeEach, we effectively require it to be executed before each of the test method is executed. This guarantees that getOpen is true and therefore a more useful test along the if branch can be created by Diffblue cover. We must now compile the Diffblue base class. We can do it here with mvn test compile. We now run Diffblue cover again. Eventually, we obtain a unit test which truly tests the logic of our broadcast method along the if branch. Note that the new test extends the base class, and this calls enable testing before the test method runs. The AfterAll annotation marks a static method which will be executed only once before unloading the unit test class and after all the unit test methods ran. Let's see an example of using the AfterAll annotation. Here we have a class named store, which contains a static method named getCombine. The class also contains a static field named dataStore. The getCombine method first sets a non-null value to dataStore, concatenates it with another string provided as parameter, and then returns the result. Let's run Diffblue cover for the store class. We will use the command dcover_create followed by the fully qualified name of the class. We get a test which correctly asserts the method logic. However, dataStore is a static field, and getCombine changes it. This means that now other classes which may rely on dataStore being null will not pass. We can use here the custom test setup technique. More exactly, we write a class named store Diffblue base in a test package after to match the location of the store source class. Inside this class, we will need a method annotated with AfterAll. This method we run after each test method ran and will set the data store field back to null. We must now compile this class, and we can do it here with Maven by using the command mvn testcompile. We should now run Diffblue cover again. Eventually, we obtain a similar unit test class with the difference that now the class extends our base class. Due to how JUnit works, extending store Diffblue base implies running the inherited reset data stored for other tests. Therefore, by running the test class and all its methods, we can now be sure that eventually, before the class is unloaded from JVM, the data store field is set back to null. Instance methods annotated with AfterEach are executed after each of the test methods finished execution. Let's see an example of using the AfterEach annotation. Here we have a class named stringUtility with a string field named cache and two instance methods. Let's focus on the second one named subbing. This method checks the value of cache, and if it finds it to be null, sets its value to a capital S followed by a space. It then returns a substring of cache starting with the index received as argument. Let's run Diffblue cover on this class using the command dcoverCreate followed by the fully qualified name of the class and the optional argument keep partial tests. Our run resulted in several disabled test methods, from which test subbing 2 is the most important because it contains an assertion which correctly states that the substring started with index 1 is an empty space. However, this assertion might pass or fail depending on the value of the static cache field at the runtime. For this reason, Diffblue cover marks the test with disabled. That means it won't run unless the user removes this annotation, concluding the subbing method is not covered at all. We'll use the custom test setup technique. Let's add a Diffblue base class for our stringUtility class. We placed it in the appropriate package, and now we are going to add an instance method annotated with AfterEach. This method is named resetCache, and we require this method to set the cache field back to null. This happens after each of the test methods is executed. We must now compile the Diffblue base class, and we can do it with the command mvn testcompile. Let's run again Diffblue cover using the same command and the optional argument as before. DibbleCover now writes a test without using the disabled annotation. Although the assertion is identical to the first one previously shown, extending the base class makes reset class run after each call to previous test methods, as those which test the first method in our class combination, and this guarantees that the cache field is set back to null. DibbleCover can now safely write assertions ready to be executed. The custom test setup technique can be used to mock a class using the Mockito framework. This option is especially important to users of the DibbleCover IntelliJ plugin. Let's inspect the class named Attributes. It has an instance field service of type service defined in the same package, and a method named operate, which adds two integers. Operate is an instance method, so in order to call it and write a unit test for it, we need to create an object of the type attribute. That's it, we'll need to use the constructor declared at line 6. This constructor initializes the service field by pointing it at the static service field of the service class. It then attempts to call the warmup method of the service class, but it obviously fails. Why? Because at line 7 in the attributes class, the service field is still null. This is due to the fact that the static fields are loaded when their class is first loaded. The service constructor shown at line 6 in the service class may set the static service field to a non-null value, but it's simply not called when the class is loaded. Let's try to write unit tests for the attributes class using DibbleCover, and let's do it keeping partial test. The command is dcover create followed by the fully qualified name of the class and the optional argument keep partial tests. DibbleCover wrote two partial tests, and they are disabled, because there is no useful assertion inside. We can see two R013 codes with the generic message no inputs found that don't throw a trivial exception. More details can be seen at line 17 and at line 35, where we can read that, as expected, the service field of the attributes class is null, and therefore a null pointer exception is thrown. We can even see that this exception was thrown at line 8 in the attributes class, more exactly inside the constructor. Concluding, programming mistakes such as this limit the unit test coverage of the whole project because unrelated methods like our operate method here remain untested. Here, DibbleCover offers a solution by mocking the service class through the well-known Mockito framework. We write a class in the test folder of the project. It must have the same name as the class from which the null pointer exception was thrown, followed by the exact words Diffblue base. That means, in our case, attributes Diffblue base. It must be placed in a test package with the same name as the source package. Here, other mocking. Inside this class, there must be two import statements, one for JUnit BeforeAll annotation and one for Mockito. This class contains a single static method named setup annotated with BeforeAll. The body of this method initializes the problematic service field to a mock of the service class. Before running dcover again, the new base class must be compiled. Here, With Maven, we can use the command mvn test compile. Let's run Diffblue cover again for the attributes class. Now we can see that Diffblue cover wrote 5 tests for the operate method bypassing the faulty initialization of the service field in the attributes class. Another way in which custom test setup technique can be used is to provide field inputs. Here we look at a very simple example. We have a class named ALL with an instance method named isAll, and this method takes a string, checks its value through a succession of if statements, and eventually returns an integer. Let's run Diffblue cover for the isAll method. The command is dcover_create followed by the fully qualified name of the method. Three assertions are written successfully. Diffblue cover is able to form a few useful string inputs and they are correctly used in assertions. However, it is not able to form the word all, which just matches the second if statement. Therefore, the method is not completely tested, more exactly, it's not tested for returning 0. As before, we can add a Diffblue base class in the appropriate package of the test folder. Here, we don't need to add an annotated method, but we can add a static string field and give it a value which is relevant to the method on the test. We'll use the word all here. We need to compile the base class. We'll use the Maven command mvn test compile. We can now run Diffblue cover again for the same isAll method. A new test class is written. It extends the base class, and as we can see, because of how JUnit works, it can directly access the bird name field from the base class. For this reason, the word all enters the first assertion, and the method is now completely tested for 0, 3, and 1. In this module, we presented the custom test setup technique as a mechanism which blends Diffblue cover with JUnit inheritance behavior. We reviewed 4 examples using all of the before and after annotations specific to JUnit. 2 more examples were shown, one for mocking classes and another one for setting field inputs. This was a brief tutorial on how to use the custom test setup technique with Diffblue cover. For more details, please visit diffblue.com.